All right, so we're going to continue to use slope-intercept form for writing equations, and now we're going to apply it to some word problems here. So remember, when we're working with a word problem, or any problem really, we want to identify the starting point. Whoops, forgot to line tool off. Starting point. And the change. So these are the words that I like to use to relate these two. Remember, the starting point means the y-intercept. That's where we see it on the graph and how we refer to it in the equation. And the change is the slope. And with the change, we're going to hear it's going to be something per an item. So in this case, we have owners of a recreation area are filling a small pond with water. So here we have a little visual. I have some owners, I have some water being added, and here's my pond. So we can visualize this happening, hopefully. I know it would be on a much bigger basis, but this is just a silly little drawing to help us. So they are adding water at a rate of 25 liters per minute. So we know they're adding at 25 liters per minute. So there we go. So this is what they're adding, and that's what that second sentence gave us. The third sentence, there are 600 liters in the pond. So I already know there were 600 liters here to start with. And every minute that they add water, they're adding more and more water. And I know how much more water. They're adding 25 liters every minute. So with this one, identifying the starting point, well, I'm starting with 600 liters, right? And I'm changing by 25 liters per minute. So the per will be different for each problem, so make sure you're paying attention. It's not always going to be liters per minute for water. It just depends on what the situation is. But there will be some idea like that. We'll say each or per. You'll get the idea. It's multiplication. So the other thing that these ones always ask us to do is use, instead of X and Y, we're using letters that represent the kind of situation a little better. So W to represent the amount of water in the pond. That's going to be our total. So instead of having Y, we have W, and we can even see that right here on the graph, W. So this is our amount of water. And we're going to let T represent the number of minutes that water has been added. So T is going to represent the number of minutes, and we can see T down here. So per minute, I'm going to have 25. Instead of saying per minute, I'm going to say 25 times T, which is just 25T. And then 600 liters is what we started with, so that's what we add the 25 liters per minute to. That's going to equal our total amount of water. So here's our equation. I just wrote it. So once we have those two pieces, we can write it. We have to replace this is our Y and this is our X. So we have to replace those, and I can even see that very quickly on the graph. If I was a little confused which one should be my Y and which one should be my X. All right, so we also get to graph the situation because they provide us with a graph here and they want us to go ahead and take a look and see what it's going to look like. So I have 600 to start with, so that's my starting point. I'm going to start with what I started with in the pond, and then I'm going to start working toward adding some water to it to get to the next point. So if you notice, these are going up by 100 each time. And if I'm adding 25 liters each time, I want to add enough to get to the next 100 because there is a little tool on here. You'll see it. It looks like this, I believe. So this is the coordinate graphing tool. And you can click on this and you can put any coordinate you want in. It's going to graph it for you. If you're using the little pencil tool, you have to graph right on top of the little crosshairs there where the lines cross. So it just kind of depends on your preference there. But for this one, if I added 25 liters of water, that means that I was only going for 1 minute. So 1 minute, and I'd add 25 liters. Well, I need to take that point away. I just noticed I was there. Times 1. So I'd be somewhere like right here. But I'm kind of guessing a little bit there because I can't really see it perfectly. But to get to 100, if I think about quarters, there's going to be 4 quarters to get to 100, right? 25 times 4, that gets me 100 more liters of water. So 600 plus the 100 I just added would get me 700. So that would be 4 minutes and 700, like that. So You can go to one that crosses very specific like that, it makes it much easier, but you can graph this one as well because I can type this coordinate in. It would be 1 minute, 25 liters, sorry, 625 liters, because we started with the 600, we added 25 after 1 minute. So I can use this coordinate tool and just type this in and click plot, and it will plot this point for me. But if you want to use the pencil tool, you need to make sure you have kind of the numbers that land right on the lines that are crossing. Sometimes we're able to do that, sometimes we're not. Because I've had problems with this one where it gives me 30 instead of something like 25. Well, I can't get 30 here. It's not going to let me work that out correctly. So I have to use that coordinate graphing tool. All right, so let me go ahead and graph my line here. Boom, boom, like that. And there we go. So we graphed our line. All right, so this next question is interpreting the parameters of a linear function that models a real-world situation. A little bit of a mouthful there. So interpreting the parameters, meaning what are the limitations? What are we starting with? What can we where are my limits, literally? So let Y represent the total cost of publishing a book. So that first sentence, they haven't told me anything necessarily. They're just starting off with let this represent a certain thing. So we must be talking about publishing a book and the cost of that, right? Let X represent the number of copies of the book printed. All right, so we're printing a certain number of copies, and X is going to be that number of copies. Suppose that X and Y are related by the equation 25X plus 1200 equals Y. And answer the questions below. So we have these questions here. So note that a change can be an increase or a decrease. For an increase, use a positive number. For a decrease, use a negative number. So they're specifically letting us know, make sure that we're putting negatives and positives in there. So let's look at this first. We need to think about the equation and what we know about what each part means. So the y-intercept is our starting point. And remember, in all of the other equations that we've been working on, that's that number that's just added to the end. That's my y-intercept. So if I go back to just mx plus b like this, that is the b, the y-intercept. It's being added or subtracted from the multiplication piece. And then the slope is the change, and that's going to be the multiplication that we see happening. So in this case, my starting point is going to be $1,200. So apparently no matter what, no matter how many books we print, it's going to cost $1,200. There must be some kind of rentals or machinery, something along those lines. It's going to be $1,200 no matter what. And then for every single book, because remember X represents the number of books, it looks like I'm multiplying by 25. So if X is the number of books and I'm multiplying by 25, it's $25 per book. Right? So now that I've kind of analyzed and I've thought about it, let's go ahead and look at the questions. What is the change in the total cost for each book printed? So we just talked about that. Each book that we print changes the cost by $25. And what is the cost to get started before any books are printed? So that would be my starting point, remember? No matter what, I can print 0 books. If I schedule this, I have to pay the $1,200. Okay, so hopefully we're doing enough books there that we can sell enough to make up that $1,200. All right, so this was kind of analyzing and interpreting slope-intercept form in real-world situations or word problems. Let's go ahead and go on, Alex, and give that a try.